Hi, I'm Patty Mullen, and I want to show you JLisp and how I use it in Buckaroo. For Buckaroo, I created a Lisp interpreter with a JSON dialect. This allows for easy manipulation of Lisp constructs through JS-based front ends. Here is an example of a scheme expression of +3, 8. It's expressed in JLisp as symbol plus 3, 8, but this is JSON. Since we have a dictionary there, we can add extra metadata about the symbol. Buckaroo leverages this heavily. Here is a more complex JLisp expression with some metadata. US date, meta cleaning strategy, cleaning column, and auto clean true. Let's see what this looks like in the Buckaroo UI. Here we have loaded Buckaroo with a data frame, and we're going to clean it. I explained the cleaning system in other parts, but I just want to show you how it works with JLisp now. So first we're going to turn on the low-code UI, which JLisp is built on top of JLisp. And then we're going to select cleaning. We're going to do aggressive cleaning. So here we can see we have 3 operations, and we can see some metadata about them. You can see this is strip int parse, US date, and they're operating on columns. We can toggle between other expressions, conservative cleaning, where we only have 1 operation, and no cleaning, where we have no operations. We can also do things like click on a column and drop that column. So here we have the low-code UI also generates Python code that does these same things, and I will show you how all of this is built without looking at front-end code. We have a variety of commands. Let's go back to aggressive cleaning. So notice here we have all these generated commands represented in pink, and we have our own command that we added. Now, what if we just want strip int parse and our drop column command? Well, we can click preserve. Actually, let's delete that, and then we'll come back. Okay. Down here, let's take a look at bw.operations now. So we see this strip int parse, and we see that metadata, and then we see our drop column command. Now we're going to preserve this. Preserving means that, hey, we like this auto cleaning method. Okay, now we're going to go over to conservative cleaning. Strip int parse stays there, and back to no cleaning. So both the strip int parse and drop column, which we put in ourselves, stay there. And let's take a look at operations again. Look at operations now, we just have these 2 commands. What Buckaroo is doing here is the front end is reading. I'm going to go back to conservative. I'm going to show you the operations. Okay. When Buckaroo sees meta auto clean true, it says, this is an auto cleaning command. And that means when you can switch to a different cleaning method, you strip out all the auto clean true. When you click preserve, it removes auto clean true. The UI also knows how to display this differently. Let's look at a different function that takes some arguments. We're on column B, we're going to do fill NA, and here we can select a different fill value. 20. Okay, there's a slight bug. But anyway, now come back to our Python code. We're filling B with 20 and doing this in place. So we are not evaluating this Python code. I'm going to show you how commands are added to the low-code UI, just below, I think. Defining a command in Buckaroo, we have a specialized class. And this class takes, has some setups, and it basically tells the UI, here are the arguments of this command, and there are different editors for different types of arguments. So we can see that we have the default JLisp, and we have the third item in the list, or from zero-based indexing, and we have a command pattern. And we're saying for the third item, call it fillVal, and type of integer. Then we write two functions. Transform, this modifies the pandas data frame and returns it. That's what's actually editing the data frame. And then we have this transform to pi. And this is Python code that writes Python code. So what we're doing here is we have two interpreters of JLisp that we send the same operations through, but one we're trying to get the Python code out of it. The other we're trying to get the modified data frame. You can also delete operations. Yeah. You can easily play with JLisp in a Python environment. So we import JLisp, and when you make an interpreter, which gives you a new interpreter with a fresh environment. So there are 3 interpreters in Buckaroo. And we've seen the transform data frame one, the transform to pi interpreter, and then I'll show you the third one in a second. So we get JLisp eval and scheme eval. We still have a scheme interpreter behind this, and you can see they do the same thing. So JLisp eval plus 3, 8, we get 11. We insert it. Scheme eval plus 3, 8, you get 11. Let's make this 9, and we're going to get an error here. Yep, we get an error. So this code is actually running. You can also pass in functions. So here, we're defining a Python function, and we're calling it add 5 to 23, and we're passing in this dictionary of symbols to this JLisp interpreter. You can set global variables. In this case, we're just doing that. We're asserting it equals 28. We can make this 29, and we're going to get 34, 35, get an error, and we want that to be 34. Next, there's heuristic lang, and I asked some of my Lisp friends, hey, I'm trying to write this language. And basically what I want to do is I have these different cleaning methods, and I want to decide which is the best one. So I wrote these rules, and basically this is saying I wrote these rules, and each rule returns the rating for that field if the rating is greater than a conditional. And f greater than 0.7 is in this one. You can send in scheme or JLisp. This is used because when you define cleaning strategies, you want to be able to quickly change heuristics, and you want it to be pretty free-floating. I'm going to be able to say, evaluate different fields and different measures and say, here's the cleaning method I recommend. And this works. Basically, let's see. And I'll explain what that macro does. 0.7 is the equivalent of greater than field, the symbol field, 0.7. But I didn't want to write the symbol field all the way, and I wanted to play with the macro. So I did. We can see the implementation up on GitHub and the unit tests. All of this is unit tested. And here we are. Define macro m less than, F greater than. Yeah. And then there are unit tests. Why Lisp? Why in Python? I knew that I needed a customized language for the low-code UI. I knew that not many people would be familiar with this language. Lisp was obviously a capable language, and one where I knew I wouldn't back myself into a corner. There's also more reference material on Lisp than whatever obscure language I would write myself. I wasn't worried about speed since the heavy lifting would be done by pandas and polars. Why not an existing Lisp for Python, like Hi? Highlang is kind of like Clojure. Clojure is to Java as Highlang is to Python. Highlang is a big language, and I wasn't trying to avoid writing Python. I was trying to give these mini languages to the users, and specifically sandbox mini languages, so that I knew here's the whole universe of functions you could ever call. This allows some safety and some, you're running this on your own machine essentially, so you can shoot yourself in the foot, but it gives you a lot of flexibility. And I just wanted to expose Python functions in a better way. If you go back up to heuristic lang, writing something like this that evaluates all these rules and returns the one that's the best fit would be a mess of if statements. And it would be a mess of if statements that I've tried to write those functions, and you would have to pass them in ways that would be very difficult. This is a better way of doing it. How did I do it? Well, I took Peter Norvig's lisp2.py and I modified the reader to accept JSON. He wrote a very basic scheme implementation. Take a look. In about 400 lines of Python. I needed to accept JSON so that I could it's easy to send the front end, have front ends great at generating JSON. Generating Lisp. And I also needed to modify it so that I could create multiple interpreters that shared no state. I think Peter Norvig wrote this as a toy, but a small Lisp interpreter is a very powerful thing. Thank you for your time, and check out Buckaroo.